telecommunications service platforms beyond IN. In the 80s, telcos used to be old PTTs, state-owned companies in charge of postal services and all sorts of telecommunications. However, since then, the telco environment has dramatically changed. Telcos need to face a new world of competition. Long ago, telcos provided a fixed set of services. Now they constantly need to conceive and provide new services. Thus, network architecture needs to be flexible to support new services that can be quickly deployed on top of new technologies. Computing has merged with telecommunications. Traditional IN applications were hard to develop. Time to market was long, and developers needed specialized training. Now, services are deployed as distributed software components. Software-based services are easy to build, test, deploy, and operate. Software can be updated, replaced, reused, or moved from one node to another. The dot-com explosion has shown a new way of offering services. The Internet appeared as an open platform. New participants started entering the service industry and creating a growing number of targeted services. Now, new telecommunications service platforms have aimed at copying this open model that fosters the creation of new services by third parties. The new paradigm of convergence has become prevalent. Services used to depend on a specific network. Now, the existing heterogeneous networks are converging, and services need to be personalized and depend on the user, not the network or the terminal. Networks have undergone a process of commoditization. The network used to be the key asset of telcos, but now the network value is constantly decreasing and the focus has shifted to services. Competing operators can only differentiate themselves by providing value-added services. Thus, operators may need to rely on external third parties to provide services that may please the users. In summary, telcos are no longer alone, so they've been forced to open up their networks to interoperate with other service and network providers. TINA. In this new context, several initiatives have started to appear since the late 1980s to open up telecommunications and merge them with computing. In 1990, a workshop created a centralized cooperative team called the Telecommunications Information Networking Architecture Consortium, TINA-C. TINA offered a new kind of service architecture for open telecommunications, encompassing flexibility for new technologies. The revolutionary concept behind TINA was to eliminate the distinction between telecommunication services and computer applications. The definition of TINA starts from a business model that is defined in terms of business domains and the reference points between them. In TINA, a service is defined as any collection of features offered from one domain to another on top of a reference point. This business model not only defines the value chain for telecommunication services, but in fact serves as an outline for the architecture itself. The separation between the retailer and connectivity provider business roles leads to the definition of two sub-architectures. Service architecture. The part of TINA in which services are executed. Resource management architecture. The part of TINA that contains the switching and transport equipment and logic. Consumer terminal applications access both sub-architectures. The TINA service architecture is based on composition and object orientation. Each service is made up of software components, each of them providing some specific functionality. The TINA resource management architecture encapsulates the technology of the individual network entities and offers a generic API to the service architecture. By doing so, TINA separates service logic from connection control. In IN, services used to communicate using switched connections. In contrast, TINA components communicate through interfaces and multimedia streams. Behind the objects, TINA provides a middleware-based computing architecture and a distributed middleware environment supporting all the services, called a Distributed Processing Environment, DPE. TINA's ideas of using object-oriented software and middleware in telecommunications paved the way for the current initiatives for next-generation service delivery platforms such as Jane and OSA. OSA Parley. TINA did not fully succeed since it tried to found telecommunications networks again from scratch. It aimed at completely redefining how telecommunications services and management were deployed. Instead, operators needed to offer a new way to access their existing networks. It should offer an open access to third parties, but at the same time, it should be a controlled, secure, safe, and billable access. In that context, BT launched the Parley initiative in 1988. Just as opponents used to discuss peace at Parley, the Parley initiative provided neutral interfaces where operators, network equipment vendors, and service providers could interact with one another. The Parley specifications are currently jointly created by the Parley Initiative, ETSI and 3GPP, also getting the name of OSA, Open Service Architecture. Contrary to IN, third parties may employ OSA Parley APIs to use network capabilities without accessing the operator's core network. OSA Parley APIs are independent of the underlying network and technology used to implement its functionalities. They only define the interfaces third parties may find, but the implementation is up to the provider. OSA defines an architecture consisting of the following roles. Applications that want to access the functionalities provided by the OSA Parley API. Servers, called Service Capability Servers, or SCS, that provide the underlying network capabilities as OSA services, called Service Capability Functions, or SCF. A framework that mediates between services and applications. When an application wants to make use of an OSA service, it must first authenticate against the framework and ask it for an access point to the service. OSA Parley consists of 10 main interface groups. This includes the framework and a set of service interfaces that allow applications to control specific network resources. Call control, data session control, user interaction, mobility, generic messaging, terminal capabilities, connectivity management, account management, charging. Parley also defined a higher level, more abstract layer of web services-based APIs called Parley X. OSA Parley APIs were much simpler than the old IN protocols, yet their asynchronous nature was still quite complex. On the contrary, Parley X is much simpler and based on request-response patterns. Jane. Java-based application servers had long been successfully used for web applications. Drawing from that, the Java community process started an activity to develop Java-based APIs for intelligent networks called Jane. Many network equipment providers support the Jane initiative, which aims at providing service portability, write once, run anywhere, network independence, any network, open developer interfaces by anyone. Jane started focusing on Java APIs for developing services within the framework of intelligent network. So the first APIs were oriented to managing SS7 protocols, abstracting the underlying networks. However, SS7 protocols are nowadays used just for integration, not for developing new mass-market applications directly on top of them. Then, Jane started moving to higher-level APIs called Service Provider APIs, SPAs, such as call control and session management. However, by that time, OSA Parley had been working for much longer on those aspects, and Jane was not able to catch up. Jane resolved to dismiss SPA and rely instead on the unofficial mappings of OSA Parley APIs to Java technology. Nonetheless, Jane has kept on developing APIs for higher-level protocols. Jane SIP is a set of Jane APIs to use SIP protocol, which is indeed one of the most successful Jane projects. Current Jane APIs also encompass presence, instant messaging, and payments. It even defines a service creation environment. But probably the best-known Jane project is Jane SLE, which does not specify interfaces but an application container. Jane Slee defines a Service Logic Execution Environment, or SLE. That is, the application environment on top of which new services run. Jane Slee is the Teleco equivalent of Java EE application servers, where services are deployed using a component-based architecture.